Welcome back, students. In this lesson, we're going to investigate the slope on a series of line segments. Let's jump straight in. So when we're connecting this to the real world, if we imagine that this path is actually in the vertical going on the y-axis and in the horizontal going on the x-axis. So the little figurine here is climbing, or the little man is climbing up. And how far does he climb up? He climbs up a rise of 2 for a run of 1. So let's see how we would how we talk about the slope here. Notice there's 2 boxes here and 1 here. So that is 2 for a rise and 1 for a run, which simply means that the unit climb, which is what slope means, how much do you climb for 1, is 2. Now he moves on, and at the moment he's neither rising nor falling. Okay, so the slope is 0 by definition. So a 0 slope is a horizontal line segment. And now he's on a gradual decline. Now notice he needs to go forward 3 to go down 1. But when we're defining slope as rise over run, so a fall is a negative rise. That's why we're seeing the -1, because he falls by 1, which is put down as -1, and he runs forward by 3. Okay, now this interpretation, which is very important, of this -1/3 or -0.33 rounded, is that for every 1 forward, I'm going to do it here, 1 forward, he goes down 0.33. Another 1 forward, he's gone down another 0.33. So that's the meaning of this. Okay, on we go. Here we're seeing the broken grey line, or we'll focus on the vertical first. Let's count 1, 2 boxes, 3 boxes. He rises 3 and he runs 4. He goes out 4, he rises 3. 3 over 4. That is a fraction exactly of 0.75. Interpretation of that is, oops, sorry, I'm messing around with the original graph. He rises 3, he runs 4. Hang on, where's my graph gone? Why isn't this? No, this is a line. Let's change that. I'm going to change that permanently in the app. But, more on that in a minute. Okay, so what the interpretation as before is that for every 1 forward he goes up 0.75. So you see, by the time he gets to the end of this box, he's not quite gone up 1, he's only gone up 0.75. And on we go. Okay, and then I have gone 4 over 14, which by the way would be the exact same as 2 over 7. If you notice here, that's 0.29, and 4 in 14 is also 0.29. And that's because 4 and 14 have a 2 in common, so that the line segment can be broken up and still land on what we call a lattice point. So that's it, guys. You can change the number of points involved, but 5 is set as the max. And you can let your... Where is he disappearing to there when I do that? Oh, it doesn't like that the vertical line is kind of breaking the rules. He probably... No, he doesn't want to come back. He does not like a vertical line, because a vertical line is impossible in many ways. Things rarely change a huge amount over no time at all. So it's just an illegal thing. Be like your position in a car couldn't just jump from being one place to another with no time at all. It's impossible. That's what makes it a non-function, and there is a non-function there as well. You know, here you'd be asked to be in 2 places at the one time. It's just not allowed. It just doesn't connect to the real world. And that's why you want this to be a function, which we'll come to some other time. Okay, as always, by the way, there's a link to this, connect this below the video. And as always, I will see you in the next one.